All right, multiplication and division with fractions is pretty easy. It's what we've done. It's what fractions are made for, okay? We are going to be using the fact that multiplying and dividing fractions is easy to do a lot of the work when we're looking at dosing at the end of this course. Adding and subtracting fractions, on the other hand, is not so easy. And the reason for that is we need to find a common denominator. All right? We need to do this common denominator thing every time we want to add a pair of fractions that don't have a common denominator. And the reason for that is, remember what denominator means. The denominator is telling us the sort of thing this is. I have 3 of one sort of thing that are called quarters or fourths, and 5 of some other sort of thing called sevenths. And if I want to be able to say what I have when I add those together, right? If someone says, hey, I have, 3 dogs and 5 bushes, let's say, how many things do I have? Well, you could say things, I suppose, but it's not like you can combine them together to say, hey, you have dog bushes or something like that. We need to be able to translate to say, okay, how can we interpret this as the same stuff? Okay, so what we're going to do is find equivalent fractions for both of these that has the same denominator. They both have the same. Okay, and so the easiest way of doing that, all right, is, or at least the least complicated way of doing that, is to just say, hey, take these two numbers and multiply them together. 4 times 7 is 28. So 28, 4 goes into 28 and 7 goes into 28. So that means that 28 can act as a common denominator. There is some fraction that is equivalent to 3/4 that has 28 as its denominator. And there's some other fraction that has 28 as a denominator that's equivalent to 5/7. So what I need to do is think, okay, what number do I need to multiply 4 by to get 28? Well, it was 7, right? That's what I did. So I multiplied by 7. And what number do I need to multiply 3 by? Well, if I multiply this one by 7, I need to multiply 3 by 7, because that way they're equivalent fractions. Remember equivalent fractions? If not, go back to that lesson. Check it out. Okay, 3 times 7 is 21. Now, on this side, to multiply 7 by something to get 28, I need to multiply by 4. So I need to multiply the 5 by 4. So in this case, I get 5 times 4 is 20. So what I get now is 21 28ths plus 20 28ths, which leaves me with 41 28ths, which I can reduce to be, let's see, what is 41 minus 28 anyway? Gotta borrow 11 minus 8 is 3. 3 minus 2 is 1. So this ends up being 1 and 13 28ths. Okay, so that's how we can add fractions. We need to, first thing, find a common denominator. Now, you don't always have to just simply multiply the two denominators together in order to find the common denominator. Sometimes there's easier ways, okay? Sometimes there are quicker ways of getting a common denominator. For example, in this situation, we have 1/2 plus 3/8. I know I can multiply 2 by 4 to get 8. So I'm just going to multiply both of these, both the numerator and denominator of this fraction by 4 to get 4/8, and I'll leave this one as 3/8. So now we have 4/8 plus 3/8 gives me 7 Learning to add is important. 7/8. Okay, so sometimes you don't have to do the multiplying both denominators together. You can just find, sometimes you can just find one, and that will work. I'll show you another example. Okay, here we have 24 as a denominator and 30 as a denominator. Okay, if I want to add 19 24ths and 29 30ths, I need to find a common denominator. But if I were to just multiply 24 times 30, I'd get a pretty big number, and it might be kind of annoying to use. So instead, what I want to try and figure out is, hey, what's a small number that 24 and 30 both go into? So in order to do this, let's first look at what are the prime factors of both 24 and 30. Okay, so the factors of 24 are, well, we know we can factor out a 2, and that leaves us with 12, and then we can factor out another 2, and that leaves us with 6, and then we can, 6 is not prime, 6, and then we can factor out a 2 and a 3. Okay, so 24 is equal to 2 cubed times 3, 8 times 3. Okay, cool. And now 30, well, we can factor out a 2, that's the first prime we could factor out, and that leaves us with 15. We can factor out a 3 and a 5. So 30 is 2 times 3 times 5. Okay, so in order to find the common denominator then, what I can do is, so to find the lowest common multiple, is just take as much 2s, 3s, and 5s as I need to get both numbers. So I need 3 2s, so that's 2 times 2 times 2, and then 1 3 is enough for 24, and it's also enough for 30, right? Now, did I get enough 2s for 30? Yeah, I need only 1 2 for 30, but I've got 3 of them already. Okay, I need 1 3. Okay, I've got 1 3. And then all I need to do is multiply by a 5. Okay, so what this is 24 times 5. All right, what's the fast way of multiplying by 5? Do you guys know this? If you multiply by 10, so that's 240, and then divide that by 2, so that would be 120, you've multiplied by 5, because if you multiply by 10 and divide by 2, it's the same as multiplying by 5. So this is equal to 120. So both 24 and 30 go into 120, and that is the lowest common denominator that we could use, or the lowest common multiple. All right, so what do I multiply 24 by to get 120? Well, I just said it's 5. That's all I need to multiply by. So 5, I'm going to multiply both these numbers by. Okay, 19 times 5, how do I do that? Well, I just said multiply by 10, 190, and then divide that by 2. So that's 50 plus 45, so that is 95. Okay, cool. Plus, now what do I multiply 30 by to get 120? Well, let's look. 30 is 2 times 3 times 5, so there's the 30 right there in my prime factorization of 120. So I need to multiply by 2 times 2, which is 4. So I need to multiply by 4. Okay, so 30 times 4 is the 120 that we're looking for. And 20 times 4, well, it's going to be a lot like 30 times 4, but minus 4. So that will be 116. Okay, and when I add these together, I'm going to get something over 120, and I need 116 plus 95. So 6 plus 5, that's 11, carry the 1. 1 plus 9 is 10, plus 1 is 11, carry the 1 again, and 1 plus 1 is 2. So 211. Okay, which is a mixed fraction, a mixed number, 1 and, well, what? 211 minus 120. 1 minus 0 is 1. 1 minus 2, can't do it, gotta borrow. 11 minus 2 is 9. So it is 1 and 91 120ths. Okay, and we check, is there any cancellations we can do here? 91 is, what goes into 90? I'm pretty sure 91 is prime. I know the prime factorization of 120. So the numbers that go into 120 are 2, 3, and 5. Does 2, 3, or 5 go into 91? Well, 2 doesn't because it's odd. 3 doesn't because if I add the digits, I don't get a multiple of 3. And 5 doesn't because it doesn't end in 0 or 5. So this is in lowest terms. So there we go. So we've added these two fractions. Okay. Now let's try adding some mixed numbers. One thing we could do is we could just convert the mixed numbers into improper fractions, in which case everything just reverts back to what we've been doing for the last bunch. And there's nothing new. You just figure out what the common denominator is, and you go from there. I'm going to show you something that's a little bit different than that. One of the important things to remember when it comes to mixed numbers is what they really mean. 5 and 7/10 is really saying 5 plus 7/10, right? And 3 and 4/45 is, of course, this is a plus there as well, 3 plus 4/45. And one of the nice things to remember about addition is we can change the order of addition and we don't have to worry, right? Subtraction, division, the order matters for those. But for addition, okay, we can change the order and everything's okay. So let's change the order. Really, there's a plus sign here and a plus sign here. What I can do now is just turn this into 5 plus 3 plus, and then we have the 7/10 plus the 4/45. Okay? You probably wouldn't write this line. You would probably just go straight to saying, hey, 5 plus 3 is 8. And now let's just focus on these fractions, shall we? So 7/10 and 4/45. So I've got tenths and 45ths. What is my common denominator? Well, what I could do here is look at what are the prime factors, right? I know 10 is 2 times 5, and those are the prime factors of 10. And I know for 45, well, right off the bat, I can tell that 5 goes into it, and 45 divided by 5 is 9, and 9 is 3 times 3. So 10 is 2 times 5, and 45 is 3 times 3 times 5. So my common denominator is going to be something that takes the 2 3s and the 5s of 45, 3 times 3 times 5, and then I need another factor of 2. That's it. So I'm just going to multiply 45 times 2, which is 90, right? So 90 is a multiple of 10, obviously. It ends with a 0, so it's a multiple of 10. And it's a multiple of 45, because it's 45 times 2. So 90 is my common denominator. So I multiply 10 times 9 to get 90, so I need to multiply 7 times 9 to get 90. Okay, so it's the 9 trick again. All right, so that's going to be, what's this, 63. 63 is 7 times 9. And then I've got 45 was being multiplied by 2, so I need to multiply the 4 times 2, so that's going to be 8. So I now have 8 plus, okay, what's 63 plus 8? That's 71. So I have 8 and 71 90ths. And that's how we add mixed numbers. So there we go. Okay, what's the difference between 3/4 and 5/7? is what this question is asking. So we're going to need to do subtraction. Subtraction is basically the same thing as addition when it comes to fractions. Our first step when we're doing either addition or subtraction is to find a common denominator. Okay, so in this case, just like before, when we were adding, our common denominator, if we look at 4, we look at 7, they're co-prime, right? 7 is prime, actually, so there's no way that we can find a number other than just multiplying them together. So it's 28, which is 4 times 7, and now if I multiply 4 times 7 and 3 times 7, I get 21/28, and if I multiply 7 times 4, I get the 28, so I need to multiply the 5 by 28 to get 20. So there we are. Now we have 21/28 minus 20/28, which is 1/28. So the difference between 3/4 and 5/7 is a 28. Okay, let's take a look at this one. We have subtraction. We've got two mixed numbers. How do we do this? Well, okay, there are ways of subtracting mixed numbers without converting to improper fractions, but there's a lot of little finicky bits if we do it that way. So I strongly suggest, if you're not that comfortable with the mathematics going on here, just convert them to improper fractions, and then it becomes pretty simple. So let's do that. First off, so 2 in terms of 15ths, well, there's 30 15ths in 2 wholes, so that makes this 34 15ths. And over here we have we've got 90 45ths, right? 2 times 45 is 90 plus 7, so that makes 97 45ths. Okay, now we need to get a common denominator, right? That's our first step when we're actually going to do the subtraction. So I'm looking here. I know that 15 times 3 is 45, because I know minutes on a clock, right? So if I multiply this by 3, right, 3/4 of an hour is 45. I need to multiply both parts by 3. So I have 45 on the bottom. What's 34 times 3? 34 times 3, 3 times 4 is 12, carry the 1, 3 times 3 is 9, plus 1 is 10. So that's 102 minus 97 45ths. So, okay, so that's 102 minus 97. 2 minus 7, can't do it, gotta borrow. Can't borrow from the 0, gotta borrow from the 1. So that makes this 10, which turns it into a 9. So 12 minus 7 is 5. So there we go. We've got our difference of 5. So this is 5 45ths. Now, this is the first time this has happened so far in this lesson, but this can happen. Sometimes at the end of, even though you've been doing everything properly, the answer that you get is still not in lowest terms, okay? So just check that at the end to make sure that you do in fact have lowest terms. 5 and 45, well, 5 goes into 45, so I've got a cancellation I can do with 1, and 45 divided by 5 is 9. So the answer here ends up being 1/9. There we go. Okay, so that covers it for addition and subtraction, which means that we are done fraction operations. We are done looking at how to work with fractions. Now what we're going to do is look at how to work with decimal numbers. All right, so we're on to a completely different thing.